Welcome to Atek TV YouTube channel. Today, I would like to show you a new feature of our Elegance wheel diamond cutting expert software, which we call it as OptiWheel. OptiWheel is a new wheel map optimization tool designed 100% by our research development team. It not only optimizes the map or path of the wheel scanned by the probe, but also helps you speed up the scanning speed by more than 5 times. Okay, let's start. For those who see Elegance wheel diamond cutting expert software first time, I would like to start from the main menu. When the machine is first turned on, you will be greeted with 4 different choices in the main menu. The first of these is New Mode. You prefer this mode when starting a new rim that you will cut for the first time. In Open Mode, you can list previously scanned and saved wheels, and you can cut by selecting from the list. For today, we will also use Open Mode for demonstration of OptiWheel. Just below you will see Free Mode. Free Mode gives you the opportunity to cut freely, as well as the possibility of deburring manually. And at the bottom you will see Pro Mode. Pro Mod is designed to save you more time, compared to New Mode, because of less warnings during all process. In fact, all the steps you see in New Mod are gathered on a single page. You can customize your machine by entering the settings menu from the button at the top right. You can change your default settings to see same values every time when you start for a new cut. You can also access the general user manual with the information button next to settings button. In addition, the information buttons within the pages provide you with usage information about that page. Normally, we prefer New Mode when starting a new wheel surface cleaning. But today, as I'm going to tell you about the OptiWheel, I'm going to show you samples on real wheels already scanned. Let's start. First, I want to start with the test number 1 example. This example represents the flat rim types you will predominantly come across. I'll be showing you more complicated wheels as I move on to other examples. When you want to profile a previously cut rim from Open Mod, it will ask you from which mode you want to open it. I prefer New Mod for now. The first step, Will Run Out, will be the step where we will visually check if there is a run out on the rim. If you want to take a picture of the rim before proceeding to this step, you can use the camera button here. With the new zoom feature, you can take a more detailed photo of the rim and place a more detailed photo in the report that will be prepared automatically at the end of cutting process. After pressing the start button and finishing the run-out testing process, I can proceed to the next step. As you know, in the next step we choose the start, finish and save points on the rim. Since we will be cutting using Open Mode, we do not need to select these points for the moment. However, if you want to change these points and measure again, you can update these points by moving the axes with the handwheel or jog pad located just below and scan in the next step. Since we open it from Open Mode, we do not need to take measurements in this step. But I want to touch on a point here. As you may remember, we were adjusting the probe pullback setting at 2 mm and the step setting at 0.5 mm when scanning a flat rim. On more recessed or offset rims or deep dish rims, these settings could reach 6 to 8 mm on the probe pullback and 0.2 mm on the step settings. Here we encounter one of the best features that OptiWheel has brought us. Especially on a rim with flatter surface, it allows you to take faster measurements by taking the step setting at 2 mm. Even if this rim isn't that flat, it can save you a lot more time by ramping it up in the middle of the process. For example, if you want to continue scanning with 4 mm while the process continues, you can speed up a rim that you started with 2 mm scanning intervals by 2x. Or if you want to scan with 8 mm, you can speed up 4x. The acceleration coefficient here is multiplied by the value you entered in the step value, and the new step value is automatically activated. What's more, when you get to difficult areas of the rim, you can slow down the step value for more precise measurements. For example, you can reduce the speed that you start measuring with 2 mm to 1 mm scanning intervals with -2x acceleration in the middle of the process, or reduce it to 0.5 mm scanning intervals with -4x. When you press in the middle of speed level adjuster, it will go back to its original speed where you enter here immediately. After completing the scanning process, we come to the cutting adjustments page, which is step 4, and a brand new button welcomes us here, which is OptiWheel. Let's go inside and see. When the page is open for the first time, the measurement you have taken welcomes you. We're going to make this measurement a lot smoother soon. I'm starting the optimization process without wasting time. During this process, I will better explain to you what the buttons below do. For your information, Elegance is controlled by an all-touch control panel. For this reason, OptiWheel has been designed fully touch compatible. You can easily do all the operations that I will do soon with the tip of your finger. You can also zoom with 2 fingers and scroll with the tip of your finger. The green line on the screen shows the measurement you took, which we call it as our reference line. You can close it by this button here. If you would like to see your reference points, you can also use this button here to make them visible. Let's get closer and look at the indentations on the surface of the rim. Now I will add my own points on this green path, which is my reference line, by touching it with my finger. You can add these points at certain intervals. I usually prefer the top of the grids here. If I select only 2 points, I get a straight line. I'm increasing my sample points to optimize the surface of the rim more realistically. I mentioned that the green path here is the measurement that we get on our rim. The red line passing just above, below, or on the green path is the cutting path that OptiWheel will give us, which we call it as OptiLine, and the dots we are using to create OptiLine is OptiMark. You can make them visible by these buttons. If your OptiLine is above the reference line, it will not be cut in the first few slices when you start cutting. If the OptiLine stays below the reference line, you will have cut more of these areas this time. To understand how much of a depth or height difference this is, you can get help from the indicator on the left that shows the intervals of the grids. Let's calculate this by zooming in by getting help from the indicator here. You can use the arrows below to make more precise adjustments. When you select any point, that point will turn yellow. After the dot turns yellow, you can use these arrows to move it up, down, right, or left. You can also change the distance coefficient from the range adjuster below. The 1's digit will change when 1 is selected, the 10's digit will be changed when 10 is selected, and the 100's digit will be changed when 100 is selected. You can use OptiWheel for intro and outro, after you have finished your settings here. If you've noticed, this was our starting point. However, by stretching this point a little, I have automatically prepared an intro for myself. You can also make the same arrangement for the outro. But also, please do not forget to set intro or outro variables on page 3. Once all the processes are done, it's time to move on to the OptiWheel process, which will give us our true cutting path. For this, I need to mention the interval setting on the left. The value you see here, set to 0.5 mm by default, tells us how much distance there will be between each point. So, as soon as we start the OptiWheel process, each dot that will appear will be 0.5 mm apart. You can change this interval by increasing or decreasing in 0.05 mm increments. Let's make it 0.3 mm and see the change. As you can see from here, we currently have 472 points. Now we can save this and get back to cutting process. For an OptiWheel cut, we always recommend starting with a minus depth. You can adjust this to minus 0.2 mm or more depending on the situation. After these points are prepared, the G-code creation process will take a little longer than the G-code creation process where you only change the depth. After completing the G-code generation process, we can move on to the simulation step. Here we can simulate with an offset value of 0.2 mm. As you can remember, we gave the depth 0.2 mm in the previous screen. So, in total, we will be simulating at a distance of 0.4 mm from the rim. After completing the simulation process by turning the handwheel on the control panel, we can move on to the cutting step. Here we complete the cutting process, and if we want to save this cut, we can go to the next page after recording. On this page, we are asked if we want to cut the same rim profile again. If you want, we can continue with this selection and cut again for the other rim of the vehicle without measuring, or we can return to the main menu.